Okay, hi everyone. I'm collecting homework number 2 here, so if you're going to pass it in hard copies, if you could just send it on up. We also have some slides for today, if you would like them up here. Anybody want some at the moment? Yeah. And feel free to close it. Okay. Anybody have homework number 2? All right. You're passing the homework in. Okay. All right. So this class is going to be mostly a hands-on demonstration of a large spreadsheet model that will help you understand the structure of how LCIs are put together. So not that many slides I want to go through. I'm going to go walk through the example that's given in chapter 5 so that we're all on the same page with that example. This is also the example that was the basis of the homework problems 5.2 and 5.3 that I decided to push off until this week. Okay, so how many of you have started chapter 5? Started reading, gone through it, maybe done some prep work on the example? All right, so if you haven't gone through it, it's not that detailed. This example is not that detailed, but it's really designed to help you understand the structure of LCI. So please be sure that you read through this chapter carefully and understand the example. Okay, it should make, I hope, a lot more sense once we go through it together. Now, unfortunately, the display over here is not working, so I'm going to have to kind of do mirror image mouse work over here. So sorry if it gets a little bit slow, but we'll just be patient with it, okay? All right. So I want to just remind you what LCI modeling is all about. This is quantitative modeling, and we're trying to compile a list of all the emissions that come out of a product system, not a product itself. I don't care about water vapor just evaporating out of your hot drink. What I care about is emissions that happen over the entire life cycle of this product. Most of these emissions you can't see. They happen in faraway places. But we want a method to be able to count all of them and add them up. And we also want a method to look at what it takes to go into this product. All the resources, the water, the energy, the non-renewable materials like aluminum, for example. We want to count all of those too. And we're going to compare different options, say, what can we do to improve the design? All right, which option is better? For example, should you buy a paper book or should you buy an e-reader? It's a really complicated question, actually. It involves a lot of different materials, a lot of different processes. That's the name of the game. Okay, so I want to go through an example from our textbook. And in this example from chapter 5, there are 3 processes, and they're going to make one reference flow, and that reference flow is set as 1 kilowatt hour of electricity. Okay? Can you see this text from the back? Is it big enough for you? Right, so that's the goal. So we're making 1 kilowatt hour of coal-fired electricity, and in order to do that, you need a power plant. Okay, so that's the first process. It's the closest one to our reference flow. It's the thing that actually delivers the reference flow, that last process, the power plant. All right? So we have this electricity coming from this power plant burning bituminous coal. All right? And we can count the emissions that occur from that power plant directly, right? Because we're combusting something, it's causing CO2 emissions and many other types of emissions. Now, we're in this class in life cycle assessment. We care about a life cycle perspective. So we're going to try to count some of the economic inputs, those technological inputs that go into this power plant. And one of those is the actual transport of the coal to the power plant. In this example, it's by train. It could also be by barge. All right, so that's one of the technological inputs. And maybe there are emissions from this process that we would want to count. And then the third part of the example is the actual mining of the coal itself. And so now we're back to the raw material extraction stage of the life cycle. And we also want to count any emissions that occur from this. There's three processes in this example. All of them could, in theory, produce greenhouse gas emissions. Right, so that's the overall schematic. Let's break it down in a more abstract way. So I'm going to draw this dotted line around each process. Okay? So here I have my electricity process, and I can go to a power plant and collect primary data. I can measure how much CO2 is in the smokestack of that power plant. Right? Or I could estimate it by doing a mass balance on carbon. I know how much carbon is in the coal. It's being completely burned, so I know how much CO2 is coming out the smokestack. I could do either of those things in order to get this number. Right? Per kilowatt hour of electricity generated in this power plant of a certain efficiency, let's say 33% efficiency, I can either measure or estimate based on an emission of almost 1 kilogram of CO2 carbon dioxide. Okay? So that's one source of emission. Now I want to add those other technological inputs. Okay? So I can also, if I want to count other types of resource inputs, like water use, for example, I could tabulate them in my unit. I'm showing that in green. Okay. I want one of these, right? See, my emission is per kilowatt hour. And my reference flow is 1 kilowatt hour because I've conveniently made them match. So for this final unit process in the process chain, I just multiply my emissions by 1. And I get total greenhouse gas emissions of that same number, 0.994 per GMC. So that's what we call a first-tier analysis. Those are direct emissions, and I'm putting them in air quotes because that's what the technical term is, direct emissions from this coal-fired power plant. Now we're going to talk about the indirect emissions. All right. In order to do that, we have these two types of inputs, the coal mining itself and the transport by train. And hopefully now you have some tools at your disposal and what you've already brought to the class, ways that you can estimate the actual quantities of these inputs. Okay? For example, with the power plant, you know, based on the efficiency of the power plant, you can do an energy balance to figure out how much coal you're going to need. Right? So let's say in this example, you need 0.442 kilograms of bituminous coal with a certain heat content in order to generate 1 kilowatt hour of electricity in this power plant. And then based on how far away you are, between the coal mine and the power plant, you can estimate the ton kilometers, which is the product of the tons of freight times the distance in kilometers. To get that melded unit, ton kilometers, in this example, 0.461. So we have those measurements now, and we can put them in this process, in an abstract diagram. So let's go ahead and do that. This was our first one. And now we're going to add the transport piece. Okay. So I have this transport coming in. Again, I can go to an actual train and measure the CO2 emissions coming out of the smokestack of a diesel locomotive, or the exhaust pipe. Okay. Or I can do, again, a mass balance on carbon and diesel fuel, and assuming complete combustion, I can figure out there's about 0.009 kilograms of CO2 coming out per ton kilometer. Right? Yeah. Oh, good. So you can kind of see that unit here. Okay. Kilogram CO2 per ton kilometer. And based on your earlier estimate, you know you need 0.46 ton kilometers to deliver enough coal to the power plant in order to generate your 1 kilowatt hour of electricity. one of these processes has been scaled to produce a reference point, 1 kilowatt. All right, and now let's do the third one. The bituminous coal at the mine, which is another indirect emission that occurs. And you can see, if you go to a coal mine, there's no direct CO2 emissions from a coal mine. There's many other types of emissions, but we're just counting CO2 here. So you would find 0 here, and it's 0 kilograms CO2 per kilogram of coal. Right, it's really important that you keep track of these units. Each unit process has its own unit. That could be kilograms. As you'll see, it could be pig place. All right, there's lots of different units that are used for life cycle assessment, and you really need to keep track of them. So, based on our measurements, you know that you need 0.44 kilograms of coal to generate your 1 kilowatt hour of electricity. So you multiply this emission by this quantity, what we call an activity total. And if you sum those up, the emissions from the power plant, right, the emissions from diesel train, and the emissions from the coal mine, which are 0, you get a new total, which is the direct emissions from the power plant and these indirect emissions from upstream. Doesn't really add a lot in this example, but a little bit to more complete. Okay, any questions on this example? Right, so if you haven't read chapter 5, please go through that. This is the example, and you'll see it laid out in numbers, and hopefully this schematic will help you interpret that. Yeah?
So how do you come to this value from 009 kilogram CO2 per ton kilometer?
So as I mentioned, there are 2 ways you could do it. You could actually go to a train and stick a CO2 monitor inside the exhaust pipe and measure the concentration of CO2. And then you could also measure the consumption of diesel at the same time. Put those numbers together and figure out how much CO2 is being emitted per ton kilometer of the train moving. Okay? So the more heavy a train is, the more fuel it needs to move a certain distance, right? And so it could be a direct measurement, or you could say, I know the train is consuming a certain amount of diesel, and then you could do a mass balance on the carbon in that diesel, because it has to go somewhere. It goes up the exhaust pipe as CO2. Right? There's no other place for it to go, assuming complete combustion. All right, so either of those methods you can use in order to get this, what's called an emission factor, emissions per unit of whatever is being delivered by that process, in this case, the ton kilometer.
And 0.461 value?
So 0.461, this is the amount of transport that's required to bring this quantity, 0.44 kilograms of coal, to this power plant from the coal mine.
Yeah. But it could be like different for different power plants, so like, is that averaged or?
So it's just an example, right? If you were doing this for real, you would say, all right, my coal is being mined here, my power plant is over there, and you would actually measure the distance. Through GIS analysis is very common to figure out how far the train is actually moving. But this is just for demonstration purposes. Okay. Any other questions on this example here? Yeah.
What about the energy needed for the equipment at the mining site?
Yeah, good question. So you'll notice, you just fed right into my narrative. You notice that there are many things that are missing. There are other inputs that go into this system. One of them, if you tried to do that homework problem 5.2 and 5.3, is diesel that's combusted for heating in this industrial boiler during coal mining. And you might want to include that. Okay? So you need to add another unit process in here that's related to the coal mining activity. In this example, the simplified one, we're leaving it out. That's called cutoff. The technical name is cutoff. And if you go through and read the ISO document, you'll see all these definitions laid out very clearly. So we're going to talk about cutoff in Monday's class, right? And how to avoid cutoff, how to incorporate all these different indirect inputs in a single matrix operation. So just save your question until then. Okay? Okay. So now we're going to look at a spreadsheet version of this. And so what I would like you to do is go to Blackboard. Please open your computer. You can work with somebody near you if you don't have a computer with you. And I want you to open this file. It's under course materials in this LCA Data Models and Software folder. And the file is called Chapter 5, Simple and Complex Models from US LCI. Okay. So it looks like this. Right, and I'm going to try to make this as small as possible. So for you guys in the back, can you tell me when you can't see this anymore? How's it now? You can't read that anymore? All right, let me blow it back up. How's that? You don't need to read the exact numbers, but can you read the words? Okay, that's fine. All right. So what I'd like to do is go through these different tabs together of the worksheet, and then I'm going to go through the example together. I'm going to show you some Excel operations, and then I'm going to give you a problem to work on to essentially build your own spreadsheet model, similar to what you see here. So what this is it's an excerpt of 3 unit processes from a database. The database is called the US Lifecycle Inventory Database. Okay, it's housed or was developed originally by the National Renewable Energy Lab, which is one of our Department of Energy laboratories. It's based in Colorado. Okay, so they put together all of these unit processes that have different reference flow outputs. And this is an excerpt of one of them. So let's just go through it together. This is the unit process for electricity from bituminous coal. Okay, so I'm going to shrink this a little bit so we can fit it over. All right, so here's how to read it. These are the different inputs or outputs. So these are the flows associated with the unit process. Over here, this is the location. Hopefully we're all in the U.S. Some elementary emissions go to different environmental compartments. Some emissions go to air, some emissions go to water, some emissions go to soil, and sometimes that's specified. So that's what you see here, this category. Right? If you know it's an air emission versus a water emission. Okay? Sometimes there's even more information, maybe it's urban air or rural air, and you'll see that specified here. This next one is infrastructure process, which we're not going to use a lot, but it applies to things that are related to capital equipment. And then you have the unit, okay? The unit of the input or the unit of the output. Right? And you'll notice that these are different. Up here it's ton kilometers, down here it's kilograms, right? And you might see other types of units as well. And then the actual value that's given. Okay. So, how do you read this? Electricity, bituminous coal. Okay. First, we have the amounts here. So, and again, I'm sorry, it's hard for me to do this without my display here. So over here, this 0.44, this tells you the input of coal that you need in order to make your electricity. Okay? And the transport from train, well, that's up here, 0.46 in this next one. So for your question, where did those numbers come from? They're from this database of people that actually went out and measured. Now, you don't have to do that. You can just use the database. This applies to an average U.S. Okay? And you'll notice there are some inputs that actually weren't included. You can see some coal could get delivered by pipeline, some coal could get delivered by truck, some coal could get delivered by barge, so over water. None of those were included in our example. Okay? But you can see them here in the actual US LCI inventory. Okay? And then you have some other things that were required. So you need some solid waste disposal. So these are the economic flows associated with electricity. Okay. Now we have the environmental flows. All right, so these are emissions associated with our coal-fired power generation. And the unit here, you can see up in yellow, is kilowatt hour. All of these flows are scaled to 1 kilowatt hour of electricity output. That's our reference flow. Right, and whatever emission you're interested in, if you've ever wanted to know how much mercury comes out of an average U.S. power plant, well, you can just look it up right off this table. So there's dozens and dozens of different emissions that are here, and you can see, again, the units in kilograms and the quantities given. Some of them are very, very small. Some of them, like CO2, for example, will be much larger. Okay. Yeah, so here's carbon dioxide. It's going to be one of the largest. All right, so what I'd like you to do is take a little time, explore these next two tabs. Explore the train diesel and the bituminous coal line, and then make sure you understand what you're seeing. If you have any questions, you can talk about them. And I'm going to ask you what economic inputs are not included in the example that we're looking at. Take a couple minutes and look at those two things. Do you have a way to open it? Yeah. So you're gonna have to work together on something. All right, ready? Yes. A specific question or a class question? If you're going to generate a kilowatt hour of electricity from coal, then take the acronym here. So this says per kilowatt hour of electricity from a coal power plant, there is 6.4 times 10 to the negative 8 kilograms of acrolein emitted, and 2.1 times 10 to the negative 7 kilograms of aldehyde. As a family of chemicals also emitted, and so on down. So those are the emissions that are coming out per kilowatt hour generated. These ones are a little bit different because these are economic flows.
Okay.
Right? They're not environmental flows. So these refer to other unit processes. So this says per kilowatt hour of electricity. I need to transport some of that coal with a barge, so like a floating ship. Okay? And I need to transport some of it by truck, some of it by pipeline, some of it from a diesel-powered train. So this is like an average for coal-fired power plant. Coal. Okay, shipped from the mine where the coal comes from. And I need to actually get the coal itself from the mine. That's that quantity, 0.44 kilograms. To use this LCI, it's built on the principle of mass balance. So it says, I know we're generating 1 kilowatt hour, and how much, what's the conversion efficiency of that process, and based on that, you can back out how much coal you're going to use. Yeah. Because none of those are infrastructure processes.
What would be an infrastructure process?
Like the coal mine itself, the whole coal mine.
Oh, okay, so like if we have like a list of
So another one, there's the transport diesel train, but you need to actually make the entire railroad. So that would be the infrastructure. Yeah, so something that's not infrastructure is tagged with a 0. Something that is infrastructure is tagged with a 1. Almost all of the unit processes are not infrastructure. Yeah, it's just, unit processes that you see there that are not in our simple processes. Which one is that? Okay.
So does this mean, this is what is confusing to me. There's whatever 0.0004 kilograms of coal combusted in an industrial boiler to make 1 kilogram of
Yeah. So in order to dig up some coal, you need to burn some coal for heating. Right? You don't want these miners to freeze.
Okay. That makes sense.
All right. So let's go through these unit processes. Let's talk about the train one first. All right. So again, just to orient you, first you look at this unit over here, ton kilometer. This is your reference flow that's delivered by this unit process. This says, for every 1 ton kilometer of my train freight transport with the diesel locomotive, I have these flows. Okay? Some are environmental flows, some are economic flows. All right, so I asked the question earlier, which one of these is an economic flow that we didn't have in our simple 3-process model? Of this list of whatever that is, 8 of them. Yeah. Okay. It's not NOx emissions, and it's important to know why. So NOx emissions are, if they're an environmental flow, okay, they're going straight from the diesel locomotive straight into the air. Okay? And you know that because it's specified here as an emission. It's an emission to air. Right? So you know that has to be an environmental flow. It's not coming from another unit process. It's not part of the economy. Right? Or another way of saying it, it's not part of the technosphere. We use that word. Yeah. Is it the refinery? It's not the refinery itself. It's diesel at the refinery. Okay? So that's right. And how much diesel do we need in order to transport freight 1 ton kilometer? Good, yeah, liters. I'm asking you this very easy question to make sure you get the units. Okay, so that's the quantity and then the units. So that's right. We counted emissions from the combustion of the diesel, but we didn't count emissions from the refining of the diesel. And maybe we can even work back up that branch of the supply chain. We could look at emissions from drilling of the crude oil, transporting of the crude oil. Maybe we had to do some cleanup of the crude oil at the refinery. We didn't count any of that. Okay? So all of that is associated with this other indirect unit process. Okay, and that's the only one, right? All the rest of them are environmental. Okay, now let's look at the bituminous coal being mined, and this is an average for the U.S. Okay, so let's look at this one, row number 9. I'd like someone to tell me in words what you see here. What does this mean in words? How do you interpret the information you get in row number 9?
Electricity used for mining coal.
Okay, now put the quantities in.
0.038719 kilowatt hour.
Okay, of grid electricity, right? It's not generated on site, it comes from the grid. Okay, in order to produce
1 kg bituminous.
of bituminous coal. Good.
Extract or produce? Extract.
We just say produce for all of the unit processes. All the outputs are producing a reference flow. In this case, the reference flow is 1 kilogram of bituminous coal. Okay? Now, let's do a couple more just to belabor the point, but it's really good that we're all on the same page. How about this one? Row number 8. Please interpret this. Go ahead. Yeah.
The volume of diesel needed for mining 1 kilogram of coal.
Okay, so how much volume?
That's about 0.041 liters.
Liters of diesel that's combusted in a boiler, presumably to produce heat, right, in order to enable the mining of 1 kilogram of bituminous coal. All right, last one. Let's do number 12. Okay, roll number 12. Elaine, please interpret.
So we have 0.0 of residual fuel oil from the boiler to produce the 1 kilogram of coal.
Good, of bituminous coal. Good. Okay, so it seems tedious to do this, but if you don't get this basic structure of this unit process and these flows, we won't be able to do anything else that builds on top of it. All right, now let's go down to row 14. This is something that's new. We haven't seen this yet. All right, so take a look at it and tell me what you think this means. It's a new kind of flow we haven't seen. No, it has nothing to do with the boiler itself, specifically. Yeah?
It seems like you're just burning that coal underground, so like probably like for mining if you need heat or light.
No, that's not what it is. Yep, Kim?
So for all these words that they're mining, and they're specified as
Exactly. Yeah, so remember from our unit process diagram, we had this unit process, we had economic inputs, economic outputs, we had environmental inputs, we had environmental outputs, right? We've mostly been talking about this one, and those emissions, we've been talking about this one. But remember, I also said LCA allows you to look at resource inputs, the amount of water you need to produce something, the raw resources. And this row here, coal bituminous at 24.8 megajoules per kilogram, that's the raw resource. And if we cared about things like how much fossil fuel is being used in the entire product system, we would want to count that. Right? That would be a metric that we cared about. So this is one of these environmental inputs. And it's very important that it's specified with enough information that we can say, this is this energy content, this is that energy content. Good. And all right, last one. Row 19. All right, and I want to call on somebody who hasn't called on yet here. How about Genlo Shi? Yeah. What do you think about it? Row 19. Did I blow it up right? How do you interpret this? Can you read this? No, it's still too small? Yeah, please tell me if you can't read it. So tell us in words, what does the information here represent? All right, is it an economic flow or an environmental flow? Actually an environmental flow. And you can tell because you can see where it's going. You can see this is an environmental input, this is an environmental output to air, and this one we're talking about now, manganese, is an environmental output to water. Okay? So someone else want to try this one? Yep.
So 5.7 that much of manganese like probably dumps into the water to produce 1 kg of manganese.
Good. At the mine. Yes. Yes. So when you're doing this in water, or rather you're doing this in words, you want to specify the quantity, the unit, the compartment, and the substance. Okay. So that might be belaboring the point here, but I'm glad we got a chance to practice this. So these are 3 different excerpts from the US LCI, which includes hundreds and hundreds of different unit processes. Okay? Questions? So this is disposal of solid waste, and it's going to a landfill. And a landfill, it's not just a hole in the ground, it's a managed part of the economy. So we call that an economic flow. It's called dummy because this unit process doesn't actually have any descriptors in the US LCI, so they made a bunch of dummy processes that they would fill in later. So basically, for our purposes, you can just ignore the dummy.
Does all the solid waste in landfill get incinerated and does it generate electricity or like something else?
So that's a different question, and we're going to have a class related to how to model waste management in life cycle assessment, and I'll give you some basic statistics around U.S. waste management then. Okay, Olivia?
You
Yes, this is all the inputs and all the outputs in a single table.
So we kind of have to interpret the input
Yeah, so in this case, the sign of the value over there usually tells you if it's an input or output, or the category that is. For resources, these are always positive inputs, and for emissions, air, water, soil, these are always positive outputs. When we talk about the computational structure, the sign will become very important when we have our kind of generalized matrix model on Monday. Okay, so let's make a little more progress here through this sheet. Okay, so I have these 3 unit processes, and let's say I want to quantify greenhouse gas emissions. That's what we did in our simple example. Okay, so what we'll do now is go to this next sheet called Simple Model, and this is right from the textbook, so go ahead and click on that sheet. And what the authors of the textbook did here is to just excerpt some factors. Okay, so they went to each of these, electricity, bituminous coal, train diesel, and bituminous coal mine, and they went down and they got this number, carbon dioxide fossil. Okay, and they just copied it. All right, and then they dumped it in this simple model, and they put it right here. Okay, so that's what you're seeing here. These numbers are just excerpted from the value there. All right, and these are the numbers on how much is in each of them. Okay, how much kilowatt hours we're producing, and in order to do that, how much transport we need and how much coal we need. Okay? So in the example, all we did was add those up. Okay, so you just multiply the activity coefficient, the amount you need, that big purple number from the visual example, times the emissions per reference flow, per kilowatt hour, per ton kilometer, or per kg. Okay, so if you look at this formula here, and let me blow it up a little bit more, right, I'm just multiplying each of these together, this one times this, plus this one times this, plus this one times this. Okay, there's an easier way to do that, and that's with an operation in Excel called sum product. Okay, and if you've never seen this before, this is what it looks like. So you just write equals sum product, and then you have 2 different number arrays that you want to multiply by each other. So you want to multiply this times this, and add it to this times this, and add it to this times this. So this is your first array, right? And you put comma, and then your next array. Close parens, and you'll get the same number, 1.003 kilograms of CO2. Okay, so how many of you have used the sum product in Excel? It's going to be really useful for us when we're building our Excel models. As they get more advanced, and they will get much more advanced. Okay, so this is just a very simple model. We're just looking at CO2. What if we wanted to look at all the other emissions? Okay, so that's what you're seeing here. So I have all the emissions. These are the environmental flows only. Flows to air, flows to water, and if you go down and there's some flows to soil. Right? So there's dozens and dozens of different substances. Some of these cause greenhouse gases, global warming. Some of them cause ozone depletion. Some of them cause human toxicity. Some of them cause acid rain. There's lots of different that stem from these emissions. But the operation is still the same. I go to my unit process, I extract all of these values, Right? You can see there are only 8 or 9 different environmental emissions here that have non-zero values. The rest of them are 0. Okay? So this is what we call a sparse matrix. It has a lot of 0 or empty values. But nevertheless, you can still put them in and then count, all right, per kilowatt hour of electricity, per ton kilometer, and per kg of coal produced, how much of these emissions do we expect? Okay. And now you do the same kind of thing. You just do a sum product here. All right. I have my activity coefficient, how much I need, times this number. Okay, that's pulled in from my unit process. All right. And so on for these different unit processes and these different environmental forces. So what I'd like you to do is go through these 1, 2, 3, 4 formulas. So go into these formula bar and make sure you understand what the formula is doing. If you don't understand, we'll go through it together. This is another important kind of just Excel hands-on thing that will be useful to know. Right, so if you don't have a computer, it's really important for this class to share it. Yeah. So, do you mean why is there a dollar sign there? So E4 is the cell E4. Cool, yep. Of coal. Yeah, to produce 1 kilogram of coal. So this tells you that there's some waste that's involved. You know, they mine 1.2 kilograms, but they only actually get out 1 kilogram. Yeah. That tells you what's the quality of the coal. If you burn it, how much heat will you get out? Okay, any questions on the formula that you see? It's a little bit long. All right. This is your chance to ask if you don't understand it. Yes, Rochelle?
Why are we multiplying? I don't really get multiplication signs, I guess, within parentheses.
Okay.
Like within each sub-parentheses, you know.
Yes. All right, so let's go through this one. All right, so this fluid butene, okay, and it's expressed not as 1 kilogram of butene, but as 1 kilogram of carbon in butene. So that's just how we express that. All right, and if you look at the formula, let me blow it up a little bit more. Oh, that doesn't actually increase inside. So, anyhow, let's forget the E4 cell at first, and we'll just look at the sum product. Okay, so this says sum product of the information from this sheet, so the bituminous coal, or the electricity from bituminous coal, and it's pulling up A14 to A65. It looks at that particular array. So let's go over to that sheet and we can look at that array. Right? Here's A14 to A65. So these are all the names of the environmental flows. So it queries that array. Okay? And then it chooses the name that corresponds to the cell in this sheet, which is A8. And in this sheet, that is our butene. Okay, so A8 in this sheet is this cell, butene. So it looks in that array to see if there's anything named butene. Okay. And then it also has this next one in the array for C of that same unit process. So it'll look up in air. Right, so it's making sure, is this the butene that goes to air or is it the butene that goes to water? And so it's choosing that unit process. And then the next one is it looks for the value in D, which, if we go back just for a second, if it's unspecified, so it goes through all of these names and so it chooses the right unit process from the subject, and then you get the value associated with that particular row, and then it multiplies that value by the activity coefficient that you specify up here, 1 kilowatt hour of electricity, or 0.44 kilograms of coal, and so on. Yeah, question?
Yeah, I just want to clarify. So the asterisk isn't like multiplication
Mm-hmm.
so it has to be
Yep. Yeah, so it's just a clever way of doing like a nested lookup table. Okay, so anyhow, there's this simple model you can use just for one substance, carbon dioxide, where you can literally just copy paste, or you can set up these lookup tables to do that automatically for you. All right, so let me go back to the slides here for a sec. Okay, so now let's, what we're going to do now is make our own spreadsheet model. By we, I mean you. So I want you to, again, work with a partner nearby. Go to the last tab of the spreadsheet that you have. It's called EcoInvent LCI, just the CO2 pieces. So what I've done is extracted a list of all the unit processes and their associated CO2 emissions. What you see in that spreadsheet. With your partner, or alone if you are working alone, think up a simple product. Okay, not your computer. Right, something simple like a chair, shoes maybe. Those are surprisingly complicated. Something where you have maybe a few different materials, and I want you to try to figure out how much of each one you need. So like with our tea kettle, how much aluminum, how much plastic. You can just estimate, or even better, you can try to look up on the web, try to find some manufacturer specifications, maybe estimate based on what you know about the product. Okay, and then go to your spreadsheet and try to match the materials in your product to actually unit processes that are listed in your database that I've extracted for you. All right? You won't always find a good match, so you have to choose the best match you can think of, and we'll talk about whether you did find a good match or not. And then you'll sum all of those up. I want you to try to build a spreadsheet model for yourself that will automatically sum your greenhouse gas emissions based on what you put in for your materials. Okay, so that's the idea here. In technical terms, if you follow the ISO document, you're looking at the foreground processes first, trying to measure how much material is going into your product, or in the case of electricity, how much other types of processes. And you're going to match that with background data that's already in the database. Okay? So you don't have to explore the supply chain by hand. You can use the stack line here to get the summary. And then you add those together to get the full greenhouse gas emissions. So that's all we're going to do. Okay, and why don't we look together one more time at this spreadsheet. I'm talking about this tab called EcoInvent LCI, the blue one on the very right-hand side. Right? And you'll see all these different operations, all these different materials. Okay, here's the quantity. Here's its kind of category, so this will help you search for them. And then this is the carbon dioxide equivalent factor. So what's the greenhouse gas emissions associated with one reference flow, in this case, of your material, your process, whatever it is. All right. Any questions on what we're going to do here? I'll just be roaming around, helping you. Okay, so see if you can build your own spreadsheet model, and once you're done, you're free to go. Okay, so let's see. Who finished? Yep.
So this one is from here This one, right?
Yep.
So this one, this left,
Mm-hmm.
we need to go to the electronics.
Do it out there.
This one? No, I think we just go to the number from the electronics.
So you're looking for sulfur dioxide.
Yeah.
Do you see anything?
No,
Yep. That's the infrastructure it had, but the actual quantity is there. Yep. Mhm. Yep. So you see the number matches?
Graphite and clay, right?
Yeah. So that number matches the row here. Whatever row you're in.
Yeah, do it for graphite.
Okay.
Or this one?
On ground.
Yep, which is yeah. So see these. It says electricity, bituminous coal. So it looks at this array, which is in a different sheet, and it tries to match that array with this cell B2457, which is in this sheet. It says air. Okay. So it looks in this array and says, is there something called sulfur dioxide? Then it looks in the next column. Is there something called air? And in the next column. Is there something called unspecified? And if all of those are non-zero, so they return true, then it says, all right, what is in this value for G, which is the actual? If you go to the process extract here. Yeah, go ahead. So G is the actual value of sulfur dioxide emissions to air. Okay? What have you chosen for your topic? Red? Okay. Okay. And did you find a bread unit process in here? There is an agriculture, see this eco-category, it says chemicals. So you see anything like that? Nothing for bread? Okay, so maybe you'll find wheat.
Yeah, we're finding all the ingredients.
We're going by the
Okay, fine.
sugar
Yep.
and then yeast
Yeast
paste.
paste, okay. And what is the reference point for your bread? Loaf of bread? Kilogram of bread? A loaf of bread. Okay. So do you know how much a loaf weighs?
Yeah, we just Googled. But that's what I'm like trying to understand. It's like 1 kg of material.
Yes.
So we divide this by how much we need for 1 loaf of bread. Right?
Correct.
Okay.
Or you'll multiply. So you'll say this number, I don't know how to read, so it says per kilogram of potassium sulfate, there is 0.4 kilograms of CO2 that's emitted.
Yeah.
Okay? but you're probably not going to need a whole kilogram of potassium sulfate to make a loaf of bread. So then you multiply it by how much you do need. So if you just need 0.01 kilograms, you multiply by 20. Okay? What did you guys use for your fry? Gloves? Okay. What, made of vinyl? All right. And do you know? Okay. That's good. And do you know how much they weigh? What's the weight of each glove?
It's 4.5 grams.
Okay, good. All right, your product should have at least 2 materials. All right? If it's just a pure material, it's going to be a really boring spreadsheet. What did you choose for your product?
The biomass electricity.
So you're making electricity from biomass?
Yeah.
All right. Is there already something in there for? Do you have a process from the database for that?
For improve, so
Where did you find this?
we only need this.
Okay. All right, so you're doing something different than what I asked. I mean, it's okay, but what I asked you to do was to use this other EcoInvent LTI, and based on what you see in your product, try to match that with what you find in this lifecycle inventory database, and then build a spreadsheet model out of that. You can either do it in a simple way or a more complex way. So, for that previous thing you were looking at, biomass, did you download that from the lifecycle inventory database? Where did you get it from?
I just download that data size from the database.
From the US LCI? Okay. Oh, yeah, of course. Yeah. Okay, good.
And it said, I looked at how it's in the video, and it said that they use recycled computer paper. Would that be like wasted because there's no recycled paper here?
Yeah.
Okay. And then, like, because it's not really, it can be either or.
So this is it's called this like an office. Right. This isn't really.
That's what they said that they use. And then they extract the ink by going through a process by adding water and then the ink rises and then like that.
Okay. I mean, what you like paper that has recycled content.
So I tried looking at it and just like these two. But
Okay. So this is the actual process. Right. So you would have the thing you just identified, the paper itself, and then the de-inking process and recycling the paper, and that would give you both of those together, recycled paper. All right. Hi.
looking for polyester, and there's two different polyesters. One says for painting, and the other one
For paintings, did you say?
yeah.
Oh,
Just
okay.
find them as a category, but also the other one is glass fiber polyester. Is that what you would put in a shirt?
Yeah, that's like recycled bottles.
Okay.
Yeah.
Oh, they do use little bottles for people. Okay. So it's
What you'll find is that it's really hard to imagine.
yeah.
Even though this is the largest database that exists commercially, it's really hard when you get the
I would
specific
think there would be
material.
more textiles. Yeah, there's like yam style.
Yeah. It's just dependent on who has done studies previously and then submitted them to the database.
And does it matter like why they did the study? Does that help categorize it?
If you had the time to look into it, that's always a good idea. That's why I asked you to look through the metadata in that whatever unit process. But so what product? Oh yeah, good. So is this one of the stainless ones, or is it aluminum?
Yeah, stainless steel.
And you know how much it weighs? Yeah, so you can look up the manufacturing specs.
We just estimated how much it weighs.
Okay. And do you have a couple different materials?
Yeah, we have the stainless
Do you want to unscrew
steel.
this?
Go for it. We have the
So you have some rubber.
rubber and then the plastic. And
Yeah.
then we also have a paint.
Yeah, it's probably coated in epoxy also. So.
Let's change that, or is it a wood cover? Yeah, we can figure out what kind of paint would be on the outside.
Hard to tell.
Yeah. Wait, so they coat the inside with epoxy?
Yeah.
Oh, okay.
Yeah, there was this a bit of a controversy. You know, this group, is it Cigo or Sig? Have you seen their water bottles? It's a Swiss company.
Oh, yeah.
And they came out and said, you know, we manufacture our products, you know, with highly pure stainless steel. They were trying to say that they're better than water bottles, but in fact, it's all coated with. So we got it going. Original biomass energy file. So.
I'm trying to choose something other, some other thing.
Okay. Just choose something simple, you know, like this. Yeah, just look, or this. Yeah, just choose something. Yeah, so you're trying to find where are these materials? Do they have matching records in this other database? Yep. So you have to answer your judge. You have to choose one. Yep. These are your choices. So you have to choose one. Choose the one you think is the best one.
Okay.
What did you guys decide for your project? Glasses.
Yeah.
Great. All right.
But
So
it's hard to choose which kind of glass.
yeah.
There,
Yeah, so, I mean, I don't expect you to be a glass expert. Just choose one that you think is a good representative.
but there are only three kind of materials from this. Plastic and glass.
Yep.
So each one of it, we should choose one of the product.
In the list. And the screws will be steel, they're not going to be iron.
Okay.
been asking me the weight of each card. Yep, so you can look up like your glasses. Does it say where they're made? Okay. Yeah. So this tells you the color. I don't see the brand, but yeah. So, but you can look up like how much do glasses weigh. Look it up. I found my shovel weighs 5.9 pounds on Home Depot webpage. You know, so at least you can figure out the total weight.
Hi, I'm looking at this.
Okay. Yeah.
So I have my closest plastic, rubber, and lead.
Okay. So lead is graphite, actually.
Okay.
Carbon has a proxy for graphite.
Okay.
Can you find it?
Yep. We can do a lot of options for you.
Yeah. Yeah, so you just have to choose one. This is a lot of the expert judgment in LCA is choosing a process, a background process that matches what you're trying to do.
Sure.
Okay? Yeah, once you find processes, you have to build a spreadsheet model to extract that CO2 and multiply it by the weight of each bit.
Okay. Yeah, I wasn't
sum it all up.
100% clear in the formula. I was trying to like mirror it, like how the values were tied in. Like I understood you're searching for these in the columns, but then I don't know how you summed it to ultimately multiply by. Like in the complex one, I don't know. I'm not following the formula.
Yeah, it's a hard formula. You don't have to follow this format. I just wanted you to understand what you're doing. But if you can think of a better way, this is not how I would have done it from scratch myself. But I will make this way.
Okay.
So yeah, if you're comfortable with the Excel modeling, you can just look at another way.
Okay.
That's fine.
Okay.
What did you guys choose for your product?
It was a cotton blend t-shirt.
Okay.
Because I thought cotton was going to be tricky. Polyester is a little tricky because there isn't enough polyester in Japan here. So I'm trying to figure out everything that's made of.
Yeah. Or if you don't find polyester, there's something that's physically similar to polyester.
Some other sort of synthetic fabric.
Yeah, like nylon.
Yeah. Should look for that.
Yeah. And it's a year-to-date basis, so it's small things.
Okay.
So sometimes that trips you up. What do you choose for? Beer. All right. So like a can of beer or a bottle of beer?
I did, well, the recipe was for like X amount of liters, so I divided it all for 1 liter.
Okay.
One of those big.
Yeah, fine. And did you find, hops and barley? I think barley is good.
Yeah, there's a lot of, I just had to like assume that every single one that they wanted was the same barley. But, and then I put a rapeseed for hops because it's also flour.
Well,
but
yeah.
there was no hops in here.
Yeah.
So I wasn't sure if it more akin to like.
It's similar to canola.
Okay. I just like.
It's an oil.
I knew they're both like flowers more. I wasn't sure exactly what to put.
It's okay. Yeah. So does it say rapeseed the whole plant or rapeseed oil? Because if you specify the oil, that'll be a bit of a bias.
Just in plant production, it was just
Rapeseed itself.
yeah.
Okay. Okay.
What is I?
Integrated. Okay. All right. What did you guys choose for your product? Table. Good. And what materials did you find for your table? Some pine wood. Okay. And And then? Okay, so some steel brackets or screws. All right. Anything else? You could also include some electricity for your table, right? Electricity to do the screwing or the sawing, and just make an estimate based on something you find.
Essays for the table.
Okay.
It's very detailed.
Yeah, maybe a bit too detailed for you. Yeah, so like 3 to 4 inputs. That's why I asked you to choose a simple product. Right? Okay, so have you found the amount for each thing yet? You need 2 kgs of wood and 100 grams of steel brackets. Yeah. Okay. It doesn't have to be perfect, right? You're just trying to make a reasonable estimate. If you were doing this for real, you would take this table, you would take it over to the lab, weigh it, take it apart, then you could know for sure. Or you can look at the manufacturer's spec, and that will often tell you. For the water input, into beer.
Like it's like drinking water. I looked it up, but I don't know where.
Oh,
Right now, if I just look water.
over here. Yeah, water should be there.
It's just like when I search water, it's like there's a lot of water stuff.
Yeah. So what? Oh yeah. But you want water. It's not a disposal process. You want water as an input. And so they should have tap water. I think there's DI water. You should find it. All right. Hi. What did you choose as your product? A steel pot. Okay. For cooking. Okay, maybe a plastic handle. Okay. Do you have a weight? 2 kgs, 3 kgs? Yeah, probably. So you need to find some specifications. Right? You need to find a good estimate for the amount of steel or the amount of aluminum, whatever the pot is made of. And then how much glass do you need also. And then, well, it's really just the mass that you need. Because you look at all of these units, it's all kgs. Right? So if you can find the mass of the material, then you can match it with this unit process. That's a background process. Okay? How about you? Oh, okay. Well, there's lots of tables in the room, so. Yeah. Okay. Yeah, so did you find a representative table? How much? Okay. Yep, looks good. Yep. And now you just have to be able to put them together. What do you multiply this? Have it automatically sum up greenhouse gas emissions for you too.
Would you have to define how much, or like what mass, like how much wood we need to build a table?
Yep.
And then
Yeah, so for each one of the components, the wood, the hardware, maybe it has rubber feet, whatever's in your table. I don't know if it's this table or some other table. Whatever's in it, you need to get the mass of each thing, or if you're talking about the energy inputs into making the table, if you want to include that, then it would be kilowatt hours of electricity, megajoules of heat. You have to estimate those in some way, and then multiply those times, and make sure the units match with the units in your database, and then multiply times the unit greenhouse gas emissions.
so with the reference code?
1K. What's your product? Okay, this font? Alright, so what's it made out of?
It's made out of plastic, but we've assumed that the cap is made out of metal.
Okay, what kind of plastic and what kind of metal?
So the plastic is taken fat.
Mm-hmm.
It's not red, so like
Okay.
choose it as a fat.
It feels like it could be very. Yeah, you can often smell if it's PVC, it has a very distinctive smell.
Okay.
And that's not this one.
Okay.
Okay, and then what's this?
We consider that as stainless steel.
Okay, sure.
So just to make things a little bit different. So
Yep.
yeah. So then we consider like 40 grams for the PET bottle, like the bottle, and like 10 grams for the steel.
All right. You could look up this manufacturer and see if you can find, it's about a 1 liter bottle. So maybe you can get an actual manufacturer estimate rather than.
Okay. Okay, that's about it. But then actually,
And now you're trying to find the.
and then how we have to like quantify the data, like after we get it, like on the next spreadsheet, how am I supposed to like put all this data? Is it exactly like this?
It doesn't have to be. Just one method of doing it.
We're confused how to put the two pieces together. Like, I know for the plastic's made out of foil, and then there's like needle for on-site work, there's needle for transportation, there's move stuff around.
Yeah. So that's why these are called background processes, because they already have that whole supply chain already calculated for you. So all you have to do is link in. I mean, literally, you're going to say 80 grams of PET times, 1.3 kilograms CO2 emissions per kilogram of PET. Plus 10 grams aluminum, stainless steel, times whatever it is, 10 kilograms CO2 equivalent per kg. So it's just a simple, it's that some product operation. And you can do it by hand, or you can do it in an automated way. Whatever you want.
So which one would each of these
The
like?
thing is that too many to choose, like when you just type like steel.
Yeah, so you have to choose one that's a good match.
Yeah. The thing is, there is
Alright, so this is the actual shaping of steel. Why don't you go to the material itself? So if you go to the metals, go up to, yeah, okay. So now just look for stainless.
okay, so it's showing you steel.
Yep.
So like I take a chromium steel or
Sure.
low alloyed one. And just
Yep. So in order to make 1 kg of steel at the steel smelter or refinery, it produces that, the whole supply chain of that steel. And then maybe you also want to process. You can go to that chipless shaping thing you were just looking at, in that category. And that'll show you, you have the steel and you want to make it into a sheet, or you want to do some stamping, which is a conforming, because this is a stamped piece. So, So anyway, if you're, yeah, shaping.
okay. So from this, like, it's given like one stroke.
You don't do steel manufacturing. It's not like I expect you to do that. You just have to choose one that you think matches with the product.
So like we selected steel, so it's like we don't need to go back like to the ISO.
No, all of that's already taken care of.
PET, like manually select the plastic, the polymer, disintegrates the polymer.
Yep, all of that supply chain.
There's no crude oil, there's nothing like.
It's already in there already.
Everything there.
Okay, let's just take a pause here. I've been around to most of the groups here who have found some interesting products to look at. And I also did a little searching. I'm looking to buy a new snow shovel. So I want to know, can I buy a low-carbon snow shovel? Let's see. So I found this aluminum snow shovel on the Home Depot website. It's 5.5 pounds, according to the website. And I can see from the shovel that it obviously has an aluminum blade, it has steel hardware, the screws and rivets, and it has a polyethylene, high-density polyethylene handle. Okay? So what I'm going to do is try to figure out, based on my understanding and estimates, if I can look in manufacturer specifications, what the quantity of each of these. Okay, so this is what you're doing right now. And then I'm going to look for that material here in my database. And maybe I'll find it, maybe I won't find it. If I don't find it, I have to choose a material that is the best match. Very frequently you don't find exactly the material you want, and so you have to choose something that's, in your judgment, the best match. Okay, so let's just go down here to metals here for a second. This is another problem with this no display. Sorry about that. Okay, here we are in metals. So I have different types of processes involved in metals. The shaping the metal is actually producing or smelting the metal, but I want the extraction itself. Okay, so I'm going to go to aluminum, and let's say this is production mix, so it includes both virgin and scrap material. All right, so I would choose this as my best match, and I would multiply the actual kgs, whatever number this is that I estimate based on my 5.5 pound aluminum shovel. I would then multiply that by the number I've given you here. Well, you can see, but I can't. So the number for the CO2 equivalent emission. All right. And that number includes the entire supply chain of making aluminum. So that's why it's called a background process. So the aluminum in the shovel, that quantity is the foreground data. The aluminum in the database is a background data set that includes all of the emissions associated with aluminum production up to that point. Okay? So you don't have to go back to bauxite mining. You don't have to include all the upstream processes based on aluminum because it's already been wrapped up in the background. So that's just to interject a little bit. So keep going with your product. Hopefully you've gotten to the point where you've figured out what materials are in your product, and you've started to figure out, well, how much of each thing, and next step is to match it, and then write some kind of program. It can be manual or automatic in order to sum up total units. All right, and whenever you're done, just call me over and just check it over, and then you can enjoy your evening. Yep, so converter steel.
Is that the same?
So this is stainless steel, 18/8 stainless steel. Converter steel, there's different steel for different purposes. But if you're talking about like screws and hardware, it'll be this stainless steel, or in this case, chromium.
And that also includes all the other processes?
Yep, taking up the iron, taking it to the smelter, all the reducing agents, all that stuff.
Like, let's for example, like wood is being processed and what they're accounting for.
What's your product?
A pencil.
A pencil, okay. So yeah, you have to figure out how much wood goes into a pencil.
Yeah, I did that.
Okay.
I just mean like adjusting the data that is in the sheet to the volume.
Yeah, so that's the trick. That's what I'm asking you to do with this sum product operation. So you have your different processes, right, or materials. It's all called a process. And your graphite, you're not the only one who chose a pencil. So you have your material, 1, 2, and then, so you need one for aluminum. Okay.
Yeah.
And then are these different options, or are you going to do all of these together?
I'm really not sure. I'm just trying to say, I don't know if this is like each step.
Technical wood dyeing. I mean, some of these are infrastructure. It's like the entire sawmill. Right? That's obviously going to have a really large. And this is the actual like a piece of equipment that chops wood in half, and the mill. So I think you don't have the wood itself here. These all look very heavy. Yeah. So you want to find a unit process in your database that corresponds to the wood itself, not the infrastructure to make the wood. Yeah, you multiply the amount of each thing times the CO2 emissions per kilogram of that material. Okay, let's see. So, where'd you get your materials? Did you bring these over? Okay. So, and this is the amount that you estimated for your bread?
Yeah.
Okay. So, this should be kilowatt hours. Not kilowatt.
Times the sum of all of these numbers,
Okay.
right? So times this.
All right, and then you have your okay, so here's your product,
Yeah, that's
and you sum them by hand, and then you have your, okay.
That's your destructive.
All right, so in words, tell me what this number is.
It says that we produce 2.073 kg of CO2 when we make 2 loaves of bread.
Okay, 2 loaves of bread, and you should specify what wheat.
400 grams is 1 loaf, so 800.
Yeah, good. Yeah, looks good. And in general, when you're making these, you want to be sure that everything has labeled units. Okay, so when you have CO2 here, you should have some kind of label that says kg. Maybe it's up here, and similar over here, your total should be labeled kg, CO2 equivalent.
For the multipliers,
Yeah, for these, your units are already here, so that's fine. Often you would say, instead of sugar, you kind of copy the number. You could also just put it as a reference, so this would equal, and then you would go to your economic sheet and just click on whatever. So that way, someone like me could track through where each of these numbers are. Okay, but otherwise looks good. All done? Yeah. All right. So, you have your shirt. Alright, and good. So you ported over all this information. So this is the
Maybe one of us did like a tiny.
the numbers you pulled over from
These are the numbers
spreadsheet.
we pulled over. One of us did
And
somewhere.
okay, can you show me how the numbers are working here?
I cannot get that to not be like you can't see it, but it's so it's that number divided by that. Well, it's so that number divided by that, and then these are added to that.
Can you say it one more time? So you take this.
So that I'm pretty sure is it's the kilograms of cotton made for 1 kilogram of CO2 equivalent from this flow. And then we normalized it by the kilograms of cotton.
So does this say you have 0.28 kilograms of cotton in your shirt, and then 0.3 kilograms of polyester in your shirt?
Yeah. Also, it works in our yes. Sweet. Okay.
So we added them together to get it. So that's high.
I don't know what time it is.
All right. I'm not sure why there are so many rows.
Well, I don't think in reality we would use all of these, cotton fibers at farms and at farms, but we include them.
Okay.
And I guess we can use to hide it and not include it. It didn't matter.
Professor, do you want us to hem this in somehow?
Well, yeah, maybe that would be a good idea. But I was just thinking more than 2.
So, we can get rid of, I think that would actually make ours more realistic if we got rid of a lot of.
Yeah.
We have 2 cotton seeds at farm.
Okay.
Oh no, yeah.
Cotton making sure process.
Yeah. Well, this is the thing that is a little confusing. So this says you have 5. I just don't know what the unit is.
So this is 5.127 kilograms of cotton per kilogram of CO2.
Okay. So usually we do it the other way. So the reference flow is set as 1 kilogram, and you would put in this column how much CO2 comes out from making 1 kilogram of cotton.
I'm freezing in here. I don't know what I'm going to do.
Then maybe we misread the chart.
Okay, yeah, so that's what this is. So per kilogram of whatever this is, there's 0.03 kilograms of CO2 emitted. So this is the reference flow, 1 kg, 1 big place. 1 cubic meter. And this is the emissions per.
We did. So we did misread it then. Yeah.
Okay. So can you take 5 minutes and
Yeah.
redo your calculation? So you have thing, and this is units required. Okay. And this is the total. All right. What do you think?
Is used at the mission at the.
Okay.
That's definitely why.
Yes. So the blast furnace, this is like you took the entire blast furnace and attributed all of its embodied emissions into only one pencil that it made. So yeah, it's a huge overestimate. You can include, so this is one of these infrastructure processes. You can include them, but you need to divide. So if your reference was 1 pencil and it makes 1 billion pencils over its lifetime, then you need to multiply it at 1 billion.
Okay.
But for all intents and purposes, let's just set it to 0. So you get 1 kg of CO2 equivalents per pencil. That seems reasonable. Yeah, looks good. Yep. So, okay, so you built it right on top of the equivalent file. I was hoping someone would do that. All right, and then you have your multipliers, and I see. So you pulled each one out, row by row. And where is
I just ended up putting the math in another column.
Okay. Oh, I see. So, and are they linked together somehow?
No, they're not.
So if I change this, can you keep it going?
No.
Oh, okay.
I haven't linked them.
Okay, you could though.
I could.
Yeah. All right. That sounds good. You could also just forget about these and put the weights right here in this column, and then have the sum product work automatically. Yeah, so that looks good. And what'd you get for a total? And what's your product? Water. Yeah, that looks good. Okay. You don't have it. Okay. So, still pretty high for a teacher.
We forgot to do. Yeah. That's all that.